record on this computer. Yep, guys. So in the DevOps, AWS DevOps material, I uploaded this document, guys. AWS DevOps material, Kubernetes, AWS EKS setup.md. So this, this is the URL. I already pasted it in the WhatsApp chat, guys. You guys can go through it and install the EKS on AWS. Okay, guys, understood?
Yes, sir.
Yeah. So AWS EKS cluster setup done or not, guys? AWS EKS cluster setup done on done, right? So I already provided the a link URL to how to. Yeah. So now the setup is done. So why EKS, guys? Elastic Kubernetes Service. It will manage the Docker containers, right? It will manage the Docker containers. So what are the Kubernetes components, guys? So what are the Kubernetes components? Guys, tell me the Kubernetes components. So why I am repeating this? Because of we need to know everything. So we need to know. So we need to know the Kubernetes is most important topics. That's the reason I am again and again and telling the again and again telling the concepts, guys. So what is that? So one is, guys, pod. Guys, what is a pod? Pod is a smallest building
Smallest building block.
block. So it contains the containers. Okay. Services. What are that? So services. So namespaces. Fourth one is replication controller. So replication controller, and fifth one is replication set. Replication asset. So sixth one is daemon set. So what is that, guys? Daemon set. Seventh one is deployment. Seventh one is a deployment. Eighth one is a stateful set. So stateful set. So ninth one is the config map and secrets. So config map and secrets. So tenth one is ingress. So ingress controller. What is that, guys? So ingress controller. So 11th one is K8s volumes. Right? We already know, right? The Docker volumes, right? Same like Kubernetes volumes. Next one is Helm charts. What is that? Helm charts. So 13th one is Grafana. What is Grafana and Prometheus? What is Grafana and Prometheus? What is Grafana and Prometheus? So 14th one is ELK setup. How ELK setup? It's a log aggregation. What is that, guys? Log aggregation. So log aggregation means nothing. So log monitoring tool. What is that? Log monitoring tool. So why this log monitoring tool? I will tell you, guys. So that 15th one is RBAC. So what is that, guys? So 15th one is RBAC. So 16th one is K8s web dashboard, guys. Web dashboard. So guys, so these all are the Kubernetes components. Guys, everyone can speak out. So what is the first component, guys?
Pod,
Second one,
services,
Services,
third one,
name,
namespace,
fourth one,
replication controller, replication set, daemon set, deployment, stateful set, config map and secrets, ingress controller, Kubernetes volume, Helm charts, Grafana and
Prometheus, Grafana and Prometheus,
Prometheus, ELK setup, RBAC,
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 RBAC, Kubernetes.
Kubernetes web dashboard.
Yeah, Kubernetes. So web dashboard. Guys, now you understood, right? You already know, right? You already know these all are the Kubernetes components. So we are learning the Kubernetes, we are learning all these. So we are learning all these things, all these components. The first one is, so what is the first one, guys? What is a pod? Guys, what is a pod? So what is a pod, guys?
smallest building block,
It's a smallest building block. Yes. So it's a smallest building blocks. So what is that? The first point is pod is a smallest building block, a smallest building block in Kubernetes cluster. It's a smallest building block. The second point is in Kubernetes, every container in Kubernetes, every container will be created inside pod only. What is that, guys? Every in Kubernetes, every container will be created inside the pod only. Inside the pod only. Guys, understood? So what is that? So for example, this is the worker node. Inside the worker node. So what it contains, guys? It contains a pod. So these all are the a pod. So in a pod, so it contains a one container or a multiple containers. So every pod contains a one container or a multiple containers. Multiple containers. Guys, understood? So these all are the pods. A pod is a smallest building block in Kubernetes cluster. In Kubernetes, every container will be created inside the pod only. Every container will create inside the pod only. The next point is pod always runs inside a node. The pod always runs inside a node. So what is this?
worker node,
This is the worker node. Yes, pod creates worker inside the worker node only. So pod always always run in the worker node only, or worker node. Okay. So pod always runs inside the node only, inside a worker node. The next point is pod represents pod represents running process. What is that, guys? Pod represent a running process, and pod means I already told you, right? A group of containers.
container,
Group of containers. Pod means group of containers running on a node. So we can create multiple pods in a single node. So guys, so we can create multiple pods. We can create multiple pods on single node, single worker node, single worker node. So pod will create on single worker node. So every pod will have a unique IP address. Guys, every pod have a unique IP address. For example, in pod contains two containers. So that IP address will share the containers. Will share the containers. So we can create pods in two ways. We can create a. Now you understood, right, guys? Guys, everyone can speak out. What is a pod? Pod is a smallest building block in the Kubernetes cluster. In Kubernetes, every container will be created inside the pod only. Pod always runs inside the worker node. Pod represents the running process. Pod means group of containers running on a node. We can create a multiple pods on a single worker node. Every pod will have a unique IP address. Unique IP address. So we can create pods in two ways. In two ways. We can create the pods in two ways. So one is interactive. So one is interactive approach. What is that, guys? So one is interactive approach. So interactive approach is nothing but so we can run the command directly. kubectl run -name something like a pod name -name pod name. Then say you can give the image equal to image name. What is that? Image equal to image name hyphen generate equal to. So what we need to create? We need to create a generator pod by v1. Version is the v1. So this is the interactive mode. So we can create the pods in two ways. So we can create the pods in two ways. In our cluster, right? We created two nodes. One is for the master node. One is the worker node. One is a master node and one is worker node. So in the worker node, yesterday we already showed, right? kubectl get pods. There is no pods running on the worker node, right? If you want to create a pod, so we can create by using the interactive mode or a. So we can create an interactive mode or a declarative mode. So what is the second? The second way is nothing but a declarative way. So what is the best approach, guys? The best approach is a declarative approach. What is the best approach, guys? A declarative approach. Kubernetes manifest YML. So declarative, in the declarative, how you can declarative, guys? How you can create our declarative approach? So by using the manifest files. By using the manifest files. Guys, understood? So by using the manifest file. So what is a manifest file? A manifest file contains so for example, a manifest file contains, what is that? Kubernetes manifest AML file. So what is that, guys? Kubernetes manifest file. Kubernetes, so manifest file. So that manifest file declaration, something like so three hyphens is the syntax. Syntax is the three hyphen. So API version. So API version is nothing but a v1. So v1. So this is the version of the API, the version of the Kubernetes. The next one is kind. What is that, guys? Kind is nothing but a so kind is nothing but it's a pod or a node, pod or deployment or there. So I will tell you. So kind. Next one is the metadata. What is that, guys? Metadata. And second, third, fourth one is spec. So this is the syntax of the manifest file. So what is the syntax of the manifest file, guys? So syntax. So what is that, guys? Guys, tell me what is the syntax? Everyone can speak out. So what is the syntax, guys?
API
Syntax is a
version,
API version, kind,
kind,
metadata, spec.
metadata,
Meta
spec.
I will tell you. I will tell you each and everything. What is API version? What is kind? What is metadata? What is a spec? So what is a spec? So I don't want to. I don't want to create. I don't want to run the. I want. I don't want to run the Docker. So Docker container manually. I can give the manifest file. I can run the manifest file. From the manifest file, it took from the Docker Hub account and pull the image and create the container. So create the a container. Okay. So create the a container. Now you understood Kubernetes manifest YAML file. So Kubernetes YAML manifest file. API version is nothing but a, so it's nothing but a version of a V1, V2, something like a version and that Kubernetes version. So kind is nothing but a pod namespace or a daemon set or a something like deployment. Those all are the kind. So kind is nothing but a what you are trying to create. So kind is nothing but a what you are trying to create. Metadata is nothing but a data of the data of the data. So spec is nothing but a, if you want to create a container or if you want to create a volumes or if you want to something like a spec is nothing but a to specify. So if you want to create a container, you can specify the container. If you want to create a container, you can specify the container. Guys, understood? So this is the API version kind of metadata spec. So something like a Kubernetes pod manifest file. So I want to create a Kubernetes file manifest file. So what is that, guys? Kubernetes pod manifest file. What is that, guys? Pod manifest file YAML. Pod manifest YAML. So we'll create the a pod manifest YAML. Pod manifest YAML. So I will show you guys. So what is that? So we can take the here, copy. So copy the same, right? So what is the API version? API version is something like a V1. So what is the kind, guys? What you are trying to create? So what you are trying to create? You are trying to create a pod. So what is the kind, guys? Kind is a pod. Kind is a pod. So metadata. So metadata contains the names and the labels. Metadata contains the data of the metadata. So we can provide the a name of the pod, something like ngnx. So ngnx. So label equal to, yeah, I will took from the, yeah. So in the Kubernetes, go to the Kubernetes. So Tomcat app pod YAML. So what this is, guys? This is a Tomcat app pod YAML. Yeah. So for example, so my Tomcat or Tomcat nginx, upload nginx, right? Nginx pod, nginx pod YAML in the Kubernetes. Yeah, we just take the simple example, guys. We're taking just a simple example. So what is this, guys? So this is a API version of E1 kind equal to pod, kind equal to a pod metadata. What is the metadata? Name equal to web server. For example, web server, name equal to web server. Spec is nothing but I already told that the specification of the containers. So what is that? The specification of the container, name equal to containers. So what is the container? Container. So hyphen name. So container name, what is the container name, guys? Web server. So container name is a web server and a image. So container name equal to web server and a image colon. So what is the image, guys? So it will take from the nginx latest then ports ports, guys. So what is the port? So port is a container port. So what is that, guys? Container a port hyphen p space container port. So container port. So 80. So what is that, guys? Container port 80. So this is a just a simple AML manifest file. So what is this, guys? So this is the a simple pod manifest file. So simple pod manifest file. Simple pod dot aml. Simple pod dot aml. So commit the changes. Yeah, guys. So this is the simple pod.aml. So API version kind equal to pod. What we are trying to create? You are trying to create a pod. So metadata. So name equal to web server. Name equal to web server. Spec. The specification. Spec is nothing but a specification. What is the specifications? Container. So container. So container is nothing but a web server. Name equal to image equal to latest to port equal to port 80. So what is the port, guys? Port is a 80 port. Okay, let's try this. Let's try this. Which one? Here. Sign into console. Yeah, EKS is activated. So I created a remote mission, right? From the remote mission, we will connect to these missions, right? So instance running, two instances running. Okay, this is in the North Virginia. Where I created yesterday other one, right? Pavan? Pavan?
Ah,
Yeah, it's in stopped state. You
I
stopped?
stopped it. Ah, yes.
Okay. Yeah, you can connect this node. So this worker node, or this one is the worker node and one is the master node. So we created a two nodes, right? So from this, so we can connect public IP address, putty, can use the putty IP address, auth appearance, right? Appearance change settings, bold 18, okay, auth credentials, EKS. Yeah, now I am connecting. So what is that, guys? What is the user? Ubuntu.
Ubuntu.
Because Ubuntu. So this is the Ubuntu user. Okay. So Ubuntu user kubectl get pods get nodes. Yeah, two nodes is created. Two nodes are created. Kubectl get pods. So what it is showing? No resources found in the default namespace. So now I am creating a file called as a simple pod.aml. So simple pod.aml. So in the simple pod.aml, yeah, I'm creating a simple pod. Yeah. So what is this? API version v1 kind equal to pod. I am trying to create a pod. So metadata name, a web server, spec containers, name equal to web server, image equal to. So it will get the image from the where, guys? It will get it from the guys. So
NJN.
so it will get it from the by default Docker hub, right? From the Docker hub, it will get it. So this is
Yes,
the
sir.
ports, the container port equal to 80. Container port equal to 80. So this is the our manifest file. So what this is, guys? So this is a manifest file. So this is the a manifest file. Yeah. So display to display the to display all pods which are created. What is the command, guide, to display the all the parts which are created? So what is the command, guys? So to display the nodes which are created. So what is the command?
kubectl get node.
Very good. Nodes. So what is the command, guys? So the command is kubectl. So guys, I already told you, right? So what is the command? What is the command? This is the CLI. This is the how you can interact with this EKS. You can interact with this EKS through. So kubectl are the open lines. So now I am using the some CLI. Now I am using the CLI. Kubectl get nodes. So if you want to display the all the parts which are created, kubectl get
kubectl get
pods. So
pod.
when I'm executing the get pods, so what is the no resources found in the default namespace? It is not created. Okay. So kubectl get nodes, we will display the nodes. Nodes already created, right? Pods is not created. So pods are not created. So how you can create the pods? How you can create the pods, guys?
Through YAML file.
Yeah, through YAML file. Yeah. So how you can YAML file is created. So what is the command to create the pod? To create the pods using the pod manifest file. So create a pods. Create pods using pod manifest file. So what is the command, guys? So the command is kubectl apply -f pod aml file. So what is that, guys? pod aml a file. So yeah, so I want to create a pod by using the kubectl apply -f kubectl -f. What is that, guys? Pod aml file. Simple aml, simple pod dot aml. Yeah, what is that? Pod web server is created. Pod web server is created. Now let's check if the pod is created or not. What is the command, guys?
kubectl get pod.
Hmm. Yeah, so before it is showing something like no resources found in the default namespace. But now, so web server is created one by one, running, 0 restarts. The age is 15 seconds. So 15 seconds ago, pod is created.
Re-
So pod is created and running. Pod is created and running. But so how you are create a container? How you are running the container by using the docker run command, right? But in one file, one YAML file, so it will create everything. It will create everything. It will get the image from the Docker Hub and it will create the pod, and inside the pod a container is running. So inside the pod a container is running. So next, describe a pod. I want to see the information, detailed information about the pod. So what is the command, guys? Kubectl describe. So describe pod pod name. So what is the pod name, guys? Web.
Simple.
No. That is the YAML file. So that is the YAML file name. So now the pod name is. So what is the pod name? Pod name is web server. What is the name of the pod? Web server. In the simple YAML file. So we created the pod, right, through the web server. Through the web server. Yeah. So what is the container name? What is the pod name? Web server.
Web
So
server.
that the web server pod name. Inside the pod, a container is running. Let's check. Let's check the kubectl describe pod name. So kubectl describe pod name. So name of the pod web server, namespace is default, priority is 0, node IP. So where it is created, in which node it is created? It is created under the, so 192.168.15.186. It's created under this IP address. It's created under this IPS. What is the IP address of the pod? The pod of the IP address is 192.168.5.38. What is that? 5.38. So this is the container ID. Image is full from the Docker IO. Docker IO is nothing but a hub.docker.com, right? So the port is 80. It's running, started. Web 70, 80, 80, true, right? So So, so pod is running. Now the pod is running. So get pod logs. How you can check the logs? So we can check the, you see. So something like a normal scheduled 80 seconds default scheduler, pulling the image and pulled the image and created the image and started the container. Created the container and started the container. Yes, understood? Yeah. Now, so what is the command, guys? So what is the command? The purpose of the command. So what is that? Describe. So describe a pod. So describe pod means get more info
Pod.
about the pod. More info about the pod. So what is the command, guys? The command is kubectl. Kubectl describe
Pod name.
pod. Pod name. Pod name. Guys, understood?
Yes, sir.
So kubectl, you see, kubectl describe pod name. Okay. Next, get the pod logs. How you can get the pod logs? By using kubectl logs pod name. What is the pod name, guys? Web server. So web server. So these are the logs of the pods. These are the logs of the pods. Get pod running on which worker node. So which worker node the pod is running? So let's check, guy. kubectl get pods, get pods -o wide. So -o, so wide. So the pod is running, web server is the pod, one by one is running, 0 restarts, 4 minutes 50 seconds ago. The IP address of the pod is so 192.168.5.38, but where it is created, in which node? It is created in the 186 node. So it is created in the 186 node. It is created under the 186 node. So this is the 186. Here the pod created on this worker node, on this instance. So on this instance, so this is the instance. The pod is created in this instance. The pod is created. The pod is created. Now you understood what is the slice? So pod logs, get pod logs. How you can get the pod logs, guys? What is the command? kubectl
kubectl
logs
logs
pod name.
o hyphen y.
No, so that is nothing but a logs. So logs, right? So but I want to display the which worker node is running on the pod. So pod is running on the which worker node? How do you know? Get pod running on which worker node. So which worker node, guys? The pod is running on. The pod is running on kubectl get pods -o wide. So -o wide, get pod running on which worker node? The worker node is so -o wide is not nothing but it will display the so the pod is running on the which worker node. The pod is running on the which so worker node. Guys, understood? Yeah. So note pods we cannot access outside. So because we deployed the nginx, right? So we deployed here nginx. Let's try to access this pod. Let's try to access this pod. So something like a public IP address. To the public IP address, http://aet. Yeah, the site cannot be reached because of the pods we cannot access outside. So pods cannot access outside. Note. So what is that, guys? Pods so
Access outside.
cannot access outside. But our application is deployed on the pod only, right? So how we can get the outside? So we need to expose the pods for outside access using the Kubernetes service concept. So Kubernetes, so what is the concept, guys? The service concept. So if you want to expose pods outside, definitely, so then the concept is a service concept. So what is the concept, guys? A service concept. Now we created the pod. So we got the pod IP address, but pod, so not pod, by default pod cannot access the outside. So if you want to access the outside, definitely we need a service. We need a service. Guys, understood? There is a link between every components, guys. So please listen carefully. Pod service. So we created the pod. So but in the pod there is a container is running. In the container our application is deployed. But pod by default, the nature of the pod, it will not expose outside. It will not expose the outside. So what we need? So we need to expose pods for outside. Definitely by using the outside access using the Kubernetes service concept. So what is the concept, guys? A service concept. Service concept is so we need to expose the pods for outside the access. So for outside access. Yeah. So we need to expose. So we need to expose pods for outside outside access using Kubernetes service concept. What is the concept, guys? Kubernetes service concept. So Kubernetes service concept. So what is a service? So what is a Kubernetes service? So what is a Kubernetes service, guys? Kubernetes, if you use the Kubernetes service, it will expose the pods outside. Kubernetes service is used to expose pods outside the cluster. So Kubernetes K8s service. What is that? K8s service is used to expose the pods outside the cluster. What is that, guys? Outside the cluster. So how many types of services are there? So we have a three types of Kubernetes services. Three types of Kubernetes service. So we have three types of we have a three types of Kubernetes services. We have a three types of Kubernetes service. So one is a cluster IP. The second one is NodePort. The third one is load balancer. So what is that, guys? Third one is load balancer. So what is the third one, guys? Third one is a load
Balancer.
balancer. So how many types of services are there, guys? There are three types of services. One is a cluster IP. The second one is NodePort. The other one is the load balancer. So load balancer. So we'll discuss load balancer later. So I will tell you now cluster port type, cluster IP and NodePort. So cluster IP is nothing but a so within the cluster, it will expose. So within the cluster, it will expose. Node port is nothing but a so outside the cluster. So outside the cluster, we need to write the service manifest file YAML to expose the pods. So we can expose the pods. So we can use the service YAML. Service YAML, right? So we need to create the service YAML. Yeah, we'll tell you. Downloads. Where is our Kubernetes? So we already knows, right? So pod life cycle. So that what is a Kubernetes service? So we will use Kubernetes service component to execute the pods. So to execute the pods, Kubernetes service will make pod accessible or discoverable inside the cluster and outside the cluster also. So we can create this service. We will get one virtual IP. So the cluster IP will be registered in Kubernetes DNS with its name. So what is Kubernetes service? Service is responsible to make our pods discoverable. What is Kubernetes service, guys? Service is responsible to make our pods discoverable and accessible inside and outside of the cluster. Service will identify the pod using the pod label and the selector. Service will be identify the pod. How you can identify the pod using the pod label and the selector. So what is that label and selector, guys? So the label and selector will be defined in the metadata. The metadata. We have a three types of services: cluster port, node port, and load balancer. Kubernetes service type, something like a service to expose the plots, cluster IP. So cluster IP is nothing but a pods are ephemeral, pods are short-lived objects. Pod IP will change, it will recreate. For example, pod, right? Pod is a short-lived object. For example, if you delete the pod, so if you delete the pod, the IP will change, right? The IP will be changing. If the container deletes, if the pod deletes, the pod IP will be changing. Pods are ephemeral, pods are short-lived objects, and pods IP will change when it recreated. So for example, this pod having the this pod having the one IP address, this pod having the one IP address, this pod. So for example, these two pods are deleted automatically. So another pod is created. There is a IP address will be changing, right? So that's the reason. So we need to expose the ports by using the node port. It's not the cluster IP. Cluster IP is nothing but a port IP. Port IP. So cluster IP, when we create the pod, every pod will get a unique IP address. So when we create a pod, every pod will get the unique IP address. So we can access pod inside the cluster using its IP address only. Inside the cluster using its IP address only. So node pods are short-lived objects. When pod is recreated, its IP will be changed so that we cannot depend on the pod IP to access. So to expose the pod access, so within the cluster, we can use the cluster IP services. So cluster IP will generate a one IP address to access our pods within the cluster. So cluster IP will not change when the pods are recreated. So when the pods are recreated, so the cluster IP will not change. So cluster IP example, for example, application architecture. So this is the user, this is the front end, and this is the back end, and this is the DB functions. So something like from the request and responses, how we'll get the outside, right? So for this purpose, we need a node port. So from front end to back end, so we need to get the information from front end to back end. So we don't know, need to expose outside. It is the internally. Internally, how you can expose? You can expose by using the cluster IP from here to here, here to here, right? So we cannot give the DB access to the end user, right? So for end users, we will give the access to the front end only means application. So within the cluster, we can use the DB access. So for this cluster IP, we can use for our backend parts. Means like a backend and a DB, right? So for this purpose, we use the cluster IP. For outside access, we need a node port. So cluster IP is within the cluster only we can access. So a case service example, for example, the front-end parts, back-end apps, databases. This is the EKS cluster. So in the node port, node port to cluster IP. For communicating between the this front-end to back-end and back-end to database, we can use the cluster IP. Because of within the cluster, we can use the cluster IP. So outside the cluster, end user wants to connect this front-end. Definitely, we need a node port. So we need a node port. Guys, understood? So EKS service example outside and inside. So this is the inside IP we using the cluster IP, outside we using the node port. So how you can create the namespace or the service manifest file. So I will show you. So we need to create another service manifest file. So this is API version service kind equal to service, here kind equal to pod. So service metadata name. So the spec type equal to spec type equal to cluster IP selector. What is the selector, guys? Java web app. So here the specifications are labels and the name, labels and the selectors. What is the selector? The same selector you can use as a label. So we can use the port 80. So it's a container port and the target port 8080. So target port is 8080. Guys, understood? So this is the cluster IP and commands. Yeah, what is a node port? Node port service is used to expose the ports outside the cluster also. So when we can use the node port service, we can specify node port number in the service manifest file. So if we don't specify the node port number, then Kubernetes will assign a random node port number for our service. So the node port numbers ranges from 30,000 to 32,767. Definitely we need to mention the node port range. Node port range. Node port service is used to expose the ports outside of the cluster. So when we can use the node port service, we can specify the node port number in the service manifest file. So if you don't specify the node port number, then Kubernetes will assign a random node port number on our service. So NodePort service. So API version v1 kind service metadata. So the type equal to NodePort, selector equal to Java app, port equal to 80, target port equal to 8080. For NodePort service, Kubernetes will assign a random port number, so we can access our service outside the cluster using the any cluster mission IP, public IP with NodePort. So enables the NodePort in the security group. So this is the node. So this is the node port, guys. So load balance. It is one type of Kubernetes service. It is used to expose our pods outside the cluster using the load balancer. So when we use the load balancer as a service, the type then, so one load balancer will be created in AWS cloud. Using load balancer URL, we can access our application. Load balancer will distribute the traffic to multiple worker nodes in the round robin fashion. So in round robin fashion, load balancer. So this is our remote mission. So this is our AWS EKS cluster. So if you want to connect, so it will connect by using the kube config we already connected. So AWS LBR load balancer. So end user uses this. So if you click the www.facebook.com, it will go to the AWS load balancer. Then it will connect by using the traffic. Traffic. So guys understood pod lifecycle. Pod is the smallest building block that we can run in the Kubernetes cluster. We are using the Kubernetes to send request to the control plane. So pod is the smallest building block that we can run in Kubernetes cluster. So we are using Kubernetes to send to the control plane to the create a pod. API server will receive the request, will receive our request and will store the request details in the etcd. Scheduler will find the unscheduled pods and it will scheduler in the worker nodes. So node agent kubelet will see pod schedule and it will fire Docker engine. Docker engine will run our container. Pods are ephemeral, short-lived of objects. Guys understood the service port? Why the service? Service component is this. Service component is nothing but so we need our pod. So we need to access our pod outside of the network also. So we can use the service. So we have two types of services, cluster IP, NodePort to load balancer. Cluster IP is nothing but within the cluster only we can access. But I want to access the node outside, right? Our application, Facebook, WhatsApp, or Instagram, whatever it may be. For that purpose, we need to provide the NodePort. NodePort is nothing but we can access outside the application also, outside the network also, and load balancer. So it will distribute the load. So we can use the three types of services. One is cluster IP service, NodePort service, and the cube under the load balancer service. Load balancer service. Guys understood? Tomorrow I will show you how to create a service YAML file, and I will create a both the service and pod in a pod YAMLs in one YAML file. So we'll show you tomorrow. So we'll create different YAML files, and then we'll create a one YAML file for pod and a service. We'll show you tomorrow. Okay, guys, understood now? Little bit.
Yes. Sir, we use one service or we can use multiple services at a time.
Yeah, we can use one service or we can use multiple services. Right?
So we
You
need to
see here,
specify in YAML file.
for example, you see here. Yeah, how many services we need for one application to run for our application? So one is
So
NodePort, one is container port, ClusterIP, ClusterIP
cluster
and
IP.
NodePort, right? So if you don't want NodePort, you can use the load balancer.
Okay.
Okay.
Yes,
Yep. Thank you, guys. Thank you. So we'll continue from tomorrow. Tomorrow we'll show you how to create a service AML manifest file and how to create a service on the Kubernetes cluster and how to access the pod outside. And we can create a one manifest file for the pod and the service, and how to apply this, how to create a service and pod AML within one AML file, and how to expose this our application on the outside. So we'll show you tomorrow, guys. Okay.
yes, sir.
Yep. Thank you, guys. Thank you so much.